Yes. Now we are going to study a very important theorem in geometry, which is Pythagoras theorem. All of you are aware what is the statement of Pythagoras theorem, or what is the Pythagorean states. So it states that in a right angle triangle, the square of the hypotenuse is the sum of the square of the remaining two sides. You can see I have drawn few right angle triangles, but from this figure, many a times it is not obvious to say that z square is equal to x square plus y square. That is, hypotenuse square is equal to the sum of the squares of the remaining two sides. Or we can say hypotenuse square is equal to base square plus perpendicular square. So this is what it states, and this is what we have to prove. So we'll be having an algebraic proof as well as a geometric proof for this. So let me just explain you the algebraic proof of it. So here we have to show that x square plus y square is equal to z square for any right angle triangle. That is, hypotenuse square is this sum of the squares of the remaining two sides. So for this, let me construct a square. I have constructed a square whose side is x plus y. So see, suppose till here it is x and remaining is y. Now again I will stop. Let this distance is x and this complete is y. Similarly, till here it is x and suppose the remaining is y. Till here it is x and the remaining is y. And when you will join these points, inside you are going to get a rectangle. Inside you are going to get a square. You can prove it also that this all angles are going to be 90 degree, and let these sides be z. So z is the hypotenuse. Clear? And inside what are we getting? We are getting a square because all angles will be 90 degree. Here, if you remember, x plus y whole square. This is a square whose area is x plus y into x plus y. That means its area is x plus y whole square, area of a square. And we know the identity that this can be written as x square plus 2xy plus y square. But at the same time, this area can also be written. This area can also be written as in the form of 4 times area of triangle, which is from triangle 1, triangle 2, triangle 3 and triangle 4. And its area is always going to be half into base into height, that is x into y, plus area of this square which is formed, which is z square, because its side is z. So here you can see this is equivalent to 2xy plus z square. This also gives me the area of square. This also gives me the area of square. If I equate this, I am getting x square plus 2xy plus y square is equal to 2xy plus z square. If I cancel this 2x square from both the sides, I am getting x square plus y square is equal to z square. So this is, we can say, an experimental or an algebraic proof of Pythagoras theorem. Now after this, we are going to see its geometrical proof also. So before going for the geometrical proof of Pythagoras theorem, we should understand one important property related to a right angle triangle. So in a right angle triangle, if you draw a perpendicular from the vertex where the right angle is there on the hypotenuse, you will get three triangles A, B, C, D. Suppose this point is D. So I am getting three triangles, triangle ABC, triangle ADB and triangle BDC. if you observe them carefully, these all three triangles, the bigger triangle ABC, ADB and BDC, they all are similar. This property we have to remember. How they are similar, I am explaining. See, in triangle ABC and triangle ADB, angle ABC is equal to angle ADB, which is 90 degree, and angle BAC is equal to BAD, which is common angle. So hence we can say triangle ABC is similar to triangle ADB. Also, in the same manner, if we consider triangle ABC and triangle BDC, angle ABC is equal to angle BDC, which is 90 degree. And here angle C is common. Angle ACB is equal to BCD. It is common angle. Therefore, I can say triangle ABC is similar to triangle BDC. And if I combine these two statements, I will get triangle ABC is similar to triangle ADB is similar to triangle BDC. Now, how to write down the correct one-to-one correspondence? I'll give you just a hint of it. See, your main triangle is ABC, where right angle is formed at B. So, I will write down ABC. And from B, perpendicular is constructed. So, see, for getting the second triangle, I have to introduce D in between AB. And for getting the third triangle, I have to introduce D in between BC. So, in this way, I can write down the correct correspondence for the three triangles which is formed. So, this way you have to remember this hint. So, let us solve the geometrical proof of Pythagoras theorem, which states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So, here I have taken a triangle. Let triangle ABC be right angled at B. We have to prove that AC square is equal to AB square plus BC square. So here I need to do construction. So I will construct or draw BD perpendicular to AC. I will draw BD perpendicular to AC. Now we had learned a relationship when a perpendicular is drawn from the right angle on the hypotenuse. It states that we know that triangle ABC is similar to triangle ADB. If you want, you can prove the way we have proven previously. Therefore, AB upon AD is equal to, I will write down BC upon BD, which can be written as AC upon AB also. So here the ratio which is of my use is these two. So I will only write down this one. Clear? So I will write it down that AB upon AD is equal to AC upon AB, corresponding pair of similar triangle. From this we can write down AB into AB. AB square is equal to AC into AD. This is the first thing which I need to get. Now, the next thing, triangle ABC, it is also similar to triangle BDC. It's also similar to that. So, we can write down that AB already we have got, now we want for BC. So, I will write down BC upon DC BC upon DC is equal to AC upon BC. Same, corresponding pair of similar triangles. From this we can write down that BC square is equal to AC into DC. Now what are we going to do? We are going to just add AB square plus BC square. So if I label this as equation 1 and this as 2, so adding 1 and 2 will give me this. What? AB square plus BC square is equal to AC into AD plus AC into DC. If I take AC common, inside it is going to be AD plus DC. See the figure? AD plus DC is what? AC. It means it is equal to AC square. So hence you have proven that AB square plus BC square is equal to AC square. Hence